The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
So, good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick information? If you all can see my screen and hear me loud and clear as well. Perfect. Thank you so much for the confirmation, everyone. So, before we get started, let's have a quick recap of what we had discussed so far. Good evening, Kashyap. Good to see you back. So, we had discussed on what exactly we mean by data science and what are the components involved under data science. And then we had discussed on the concepts of just a moment. And then we discussed on how what exactly a day in data scientist life looks like. And then we had discussed on the components of EDA as an exploratory data analysis, how exactly EDA looks like in terms of giving us the access to resources that is required for performing the we can say a better analysis on the entire data set. And then we had discussed on the concepts of different components of EDA, starting with data pre-processing, how we can work on data pre-processing. And then we had discussed on the concepts of outlier detection, how we can work with outliers, how we can work with missing values, how we can work with data inconsistencies, how we can work with the box plot as a part of a discussion. And then we had discussed on how we can find out the box plot by finding the minimum, maximum, the median, the first quartile, and third quartile values. And then we had discussed on the concepts of the scatter plot, where exactly you use scatter plot and how we can get started. And towards the end, I had asked you all to get the access to Colab in case you want to work on the cloud notebook, so we can go ahead and work on Colab offered by Google, and we had to go through the content available for random forest and solving all the quiz as well. So now we are going to start with day two. So to get the access to the code, again, for now, some of you may not have the access to the LMS. So in case you don't have the access to LMS, then again, not to worry on that. You can simply get in touch with support team and they will be sharing you the credentials in case you don't have the access yet. And to get the recordings for yesterday's session, we can navigate to the section which says class recording. And this is going to take us to yesterday's class recording where we can go ahead and watch it for endless number of times. Now, to get the access to the code and the dataset that we are going to work with, we can navigate to day two of the content available in the LMS. And here we can click on code. So this is going to download the notebook file. That means the Python notebook file that we are going to work with. And then we can click on dataset to get the access to the entire data file that we are going to work with. So here we'll be taken to Kaggle's website, so where we can sign up, and then we can see here we have the access to the data file, which is for almost 920 MB. So this is what we have to download, and we can click now. Once we have signed up, we can click on download all, and then we would be able to download the file locally. So if in case we want to work locally on this analysis, we can go ahead and use Jupyter Notebook as well. So whatever is comfortable for you all, you can go ahead and use it. For example, we want to work on Jupyter Notebook. We can open this up. And then we have to simply make sure that okay, we do have the access to, that means we do have the access to the same data that we have imported. And if you are going to work, no, Jupyter Notebook is recommended for those who are having the access to a good system where we don't have any kind of lags whatsoever, because when we are working on any analysis locally, then we do need a good computation power, and for that only we do need a good capacity system. So in case we don't have the access to a good capacity, a good system, then we can go ahead and make use of Google Colab as well. But if we are trying to work with Google Colab, so we have to make sure that we do upload our data. So once we have the data set downloaded, so we have to upload both train and test data sets in Google Drive. Then only we can make use of it. All right. So here we are going to work now. Once we have the notebook file downloaded, we can simply go ahead and click on workshop, and this is going to upload the file, and then we can get started. Can you please share the link? Sure. So for getting the access to Kaggle worksheet, we can let me share this link. Here we go. So here's a link to get the access from Kaggle. So we can sign up and then we can click on download now. And once we have the notebook file available with us, we can go ahead and upload it directly in the Google Colab notebook. And then we can get started. So can you please show how did you load? I haven't shown you that yet. So currently we have just opened up Colab. So I'm going to guide you on that part, Edurika Guest. And for guys, those who have joined by the name of Edurika Guest, I would recommend you to all to kindly just add your name towards the end of your question so that I can address you by your name instead of referring you as Edurika Guest to avoid confusion for others, those who have joined with the same name. All right. So just when you're asking the queries, then please do add your name towards the end of the question so I can address you by your name. All right. Not separately, but again, along with the question, because then only I can know, okay, the question and again who has asked this question. All right. Thank you. Now, once we have the access to this notebook file, before we can make use of it in Google Colab, we have to also upload the files that we have downloaded. So first of all, we have to make sure that we have both the files available, and then we can navigate to our Google Drive. And under Google Drive, we can create a folder. So we have made a folder by the name of PUBG Battle Royale Workshop 2. And in this folder, in our own Drive account, we have added these files, training and testing CSV file that we have downloaded from Kagel's website. That has the link for which I have shared with you all. All right, so we have to make sure we do have the access to these files and we do upload. Now we can name the folder anything we want. There's no restriction, there's no guideline. And Colab, do we need to use GPU? We can use GPU there. Sonu. All right. Now, once we have the files up, Saloni, again, there's no explanation here. We only have to download the file from this website called as kaggle.com/PUBG Finish Placement Prediction. And once we sign up, once we have the files downloaded locally, then we have to create a folder in Google Drive. We can name the folder anything. And we have to upload the files that we have downloaded here from here in this drive, right? Then once we have the files uploaded, then we can download the notebook file that we have got the access to. So once we download the notebook file, we have to go to Google Colab, colab.research.google.com. We just sign up and then we can click on file and here we have upload notebook. So once we click on upload notebook, we simply have to upload the notebook that we have downloaded. And this is then the screen is going to be opened up as you can see here. All right. We are on this part now, Saloni. And Sahil, so in case you have no problem, Sahil, so in case you were absent yesterday, so you can get the access to yesterday recording by going to the LMS. So here we have class recordings and you will be able to find the recordings for yesterday's session. All right. All right. So once we have the access, now we have to make sure that we are having the data uploaded in our drive, and then we have to mount that drive to our notebook. So let's do one thing. Let's remove this code for now. So once we have the access to the file here, we have to make sure that in order to work on the analysis, we have to connect our Google Drive with Colab. Then only Colab can fetch data that has been stored in Google Drive, correct? I repeat, to work on the analysis, we have to make sure that we are going to connect our Google Colab with Drive. Then only Colab can access data stored in a Google Drive, correct? And that's why in Google Colab, we have to first of all mount our Google Drive. So for mounting the drive, we have to click on the third icon available in the left sidebar, which says Files. So under Files, we have to click on Files and wait for a couple of seconds till this screen is visible. And once this screen is visible, we have to click on this icon which says Mount Drive. The third icon available here. So here we have Mount Drive, and once you click on Mount Drive, a code is going to be added. As you can see here, this code has been added here. Now, the entire notebook is in Python. The entire notebook here is in Python. So here we can see a code has been added as from Google Colab. We are going to import Drive. From Google Colab, we are simply importing Drive here. And then we have to type in drive.mount.content. And then here we have to define the path of the content that we are going to add. All right. So this is what we are going to create here. So once we have successfully mounted it, so basically to mount it, I repeat, this code has to be executed and entire notebook is in Python. So to run this code successfully, we have to simply click on the code and then we can simply scroll up and here we have the play button, right? So to mount the code here, we have to simply click on play button. So play means we are simply going to execute the code. And once we run this code, this is a link that we are going to get. Now, in case you're doing anything else, and I would recommend you all to please stop doing anything else and focus on what we are doing right now. Do not try to do the same thing at your end parallelly, because if you do that, then you are going to divide your focus, right? And if your focus is divided, then you're not going to understand a thing that what we are discussing here, because you will be having the access to recordings anyhow, right? But this live session is something that you are not going to get again. So I would recommend you all to first of all focus entirely on what we are doing right now. And once we are done with the workshop, you can sit down in peace and then you can simply watch the recording and then do the hands-on at your end by taking it as a reference. All right. So once we have run this code, then this is a link that we are going to get. And once we click on this link, we would be taken to a sign-in page. So here we have to choose the account. For example, our drive here is in our own Gmail ID here. And then we have to give permissions. Then only Colab can access the data stored in a Google Drive, right? So this will be separate for everyone. And once you click on allow, we would be able to get an authorization code. So this authorization code is what we have to copy from here. And then we have to go back and insert here as a part of authorization code here. All right. So once we enter this code, we have to wait. And if the code is correct, then our drive would have been successfully mounted in our Colab notebook. So are we clear on this process of mounting the drive? Please give me a quick information, everyone. Nikhil, as we had mentioned, so we have to just click on the link that is going to be given to us. We only have to press accept. We have to choose the email, press next, and then we would be getting the code. And this code is what we have to copy and enter here. And then we can simply press enter. And then the drive is going to be successfully mounted. Is it clear now? And Educa guest, so we don't have any slide how to mount the drive, because I think you would get more information by seeing this hands-on as compared to any PPT slide, right? And as we discussed, again, we are not going to cover any slide. So we here simply have to run this code, and then we have to click on the link. We have to click on verify, and this code is going to be generated that we have to copy and insert back here. That's it. All right. So once we have the drive mounted, then these are the libraries that we are going to work with. So we have to import these libraries first. We are going to import NumPy for calculation as NP. We are going to import pandas as PD for working with data frames. We're going to work with import matplotlib and cmon. So matplotlib and cmon, they are used for the data visualization, for creating multiple, we can say, visuals in terms of graphs, in terms of heat maps and charts. Iter-tools is simply going to be used for performing iterations, repetitions. Warnings are basically used for ignoring the warnings that is going to be generated when we are going to work with it. All right. So we have to first of all import these libraries. We can run the command, and all of these libraries are going to be imported so that we can make use of it. Now we have to reduce the memory usage. The size of PUBG data set is pretty big, for a lower mid-range laptops, almost close to 1 GB. So here's a script to make data sets smaller without losing information. So how exactly it achieves that? By iterating over every column. It simply determines if the column is numeric. It determines if the column can be presented by an integer. And it simply finds a minimum and maximum value defined. And it simply determines and applies the smallest data type that can fit the range of given values. So this will help us in reducing the weight by almost 70% as well, right? So basically, this is a script that is available under Kaggle. So let me share this link with you all so we can use it as a reference. So this is a link available that we can go ahead and refer to. Let me share this link. So this is a script that allows us to compress the data set, and this can be applied to any data that we have. So basically, using these parameters, it is going to simply compress the data, and then it is going to give us the result. So here we can run the script, and then we have to load the CAC file to data frame. So basically, here we have defined the reduced memory usage as a function. We have defined reduced memory usage as a function in Python. And this function is what we are going to make use of to compress the files that we have uploaded in our Google Drive. So here we are going to create a train data set. And under train, we are using the pandas library as PD that we have already imported. We have imported pandas as PD, numpy as NP, and so on. So we are going to make use of pandas library and read underscore CSV. This is a function. This is an inbuilt function available under pandas library. So, and then we have to specify the path where we have the file. So this file is currently uploaded in our Google Drive and under this folder, PUBG Battle Royale Workshop 2. So this is a folder name, and here we have file as train v2 CSV and test v2 CSV. So once we have successfully mounted the drive, then we can simply specify the file path here, both for training data frame, and again we are also going to make use of the reduced memory usage. So on the data frame that has been created, the script is going to be run that we have imported right now from the given link. And then the same thing we have to run on the testing data frame as well. So basically, when we are working on analysis, we divide the entire data set into testing and training, we can say training setup. Because let's say when we are working on creating any test, so first of all, we have to make sure that we suppose if there are 1,000, if we are 100 rows in a given data, so we train the model by using 80 rows, and then we test if it is working fine or not on the remaining 20 rows. Because if we train it by using the entire 100 rows, then we are not going to know if the model is accurate or not, correct? So we train on mostly 75 to 80% of data, and the remaining 20 to 25% of data is used for testing. And that's why we have two files, one for training and one for testing. All right. Can we just give the URL to load data from drive? No, we cannot, Educa guest. We have to simply mount the drive first because the direct link is not going to work here. That's why I have shown you how we can mount the drive. All right. So first of all, we have to mount it the way I have shown you all. And then we can run the script here. So this is going to read data available in this location, and then by using the reduced memory usage function that we have created, the data is all going to be compressed, and the output is going to be displayed here. We don't split in one file, Amit. We split the files in two different files itself. Because for larger and more complex data set, it is recommended. All right. Can we train that model without compressing data? We can, Educa guess, but again, that will require unnecessary more time, right? Because let's say we have 1 GB of data, and then we have the same data which has been compressed into 400 MB. So which one would be faster? Obviously the compressed data, right? So why to waste time in that? And that's why we had to always work on compressing data first, because as you can see, a 983 MB file has been compressed to 339 MB, and 430 MB file has been compressed to 140 MB. So obviously it is going to be much faster to work on analyzing these files as compared to traditional files, right? That's why it's always a good practice to compress the files before even we can think of analyzing the data set. Is it clear now? And again, a small humble request, guys, for those who have joined with the name of Educa Guest. So kindly just add your name towards the end. That's it. So that I can address you by name instead of calling you out as Educa Guest to avoid confusion for the other participants, those who have joined the same name. All right. Now, once we have the file loaded, now we can simply see the file if it is working fine or not. So here we can define trained or info. Info is going to give us information about the data pointers available under the train data frame. So here we can see here we have 28 columns currently available. We have ID, group ID, we have 29 columns. We have ID, group ID, match ID, boost, damage gel, kills, kill streaks. Again, these are the different data sets available. And to simply print the first 5 rows, we can use train.head, and the first 5 rows of the given data set is going to be printed, as you can see here. Now, before we can start working on the analysis, we have to know our data first. So we'll be using data collected by Kaggle via PUBG Developer API. And the data set comprises of 65,000 games worth of anonymized player data, split into training and test data. So for the purpose of this EDA, we are only going to be looking at the training data set. And the training set comes in the form of CSV file, which contains 113 million individual data pointers in 26 columns and 4.3 million rows. And then we have group ID. So basically group ID refers to the group. Now every group in a game is going to be given a unique group ID. Then we have match ID, which refers to the ID given to every match. Then we have assist. So assist is basically the number of times we have helped a friend when he killed an enemy. So these are all data pointers related to PUBG game. Boost is the number of boost items used, which includes energy drink, painkillers, adrenaline syringe. And we have damage dealt, total damage dealt. And again, then we have DBNOs, which refers to down but not out. And then we have headshot kills, number of enemies we kill with headshots, heals, number of healing items used. Then we have kill plays, the ranking in match in terms of number of enemy players killed. Then we have kill points, which is basically the kills base external ranking of player. Then we have the number of enemy players killed. And then we have the kill streaks. That means the maximum number of enemy players killed in short amount of time. And then we have longest kill, which is basically the longest distance between player and player killed at the time of death. Then we have maximum place, worst placement we have data for match. Then we have number of groups available, number of revives. The right distance is total distance traveled in vehicle. Then we have road kills, number of enemies killed while traveling in a vehicle. Then we have swim distance. And then we have the swim distance, and we have team kills. The number of times we have been killed by, again, times we are killed by your teammate. And then we have vehicle destroyed, number of vehicles destroyed, the walk distance, the weapons acquired, the winning points, winning plays percentage, and then we have the target of prediction, which is basically the target variable. So this is basically a percentile winning placement where 1 corresponds to first place and 0 corresponds to last place in a given match. It is calculated off to maximum place, not number of groups possible. All right. And then we can simply type in train.tail, which is basically going to print the last 5 rows. So Head prints the first 5 rows, and tail is going to print the last 5 rows available here. All right. So now we are going to work with outlier detection and anomalies. So no data set is 100% clean. That's the fact, right? No data set is 100% clean. That's a fact. And that's why we have to make sure that we remove all the anomalies before we can even think of downloading that data set for our analysis, right? So some of data does not reflect the core gameplay because it is drawn from custom game modes or because it has fraudsters. And some of the characteristics of this enormous data includes many kills without moving, many road kills without while driving a very short distance. If suppose the players they have suspiciously high number of kills and suspiciously long range kills as well, right? So basically, we have to also have corrupt data. So due to issues with the API, there's a bug with the group ID column. So during the game, if a player leaves a match and then rejoins, then group ID is reassigned. All right. So basically, in terms of the group ID, we know that they can be a group of maximum 4 members, not more than that. That means in a game where we have maximum 100 players, technically there should not be more than 100 groups. There should not be more than 25 groups, correct? But since when the player rejoins, a new group ID is going to be assigned. That means due to this bug, we have more number of group IDs than what should be allowed. So that's a bug. And then we have users adjust. So some features like match ID is only useful for feature extraction. Some IDs are useful for only for feature extraction, such as finding total players in a match, because match ID is the hex identifier string. It is not ordinal and has a very high unique value count. So we cannot hot encode into a categorical data set. And again, we can find and we can simply agree that match ID is something that has nothing to do with the analysis, right? So this is something that we can drop. All right. So here we are going to work on, first of all, the EDA as an exploratory data analysis. Then we are going to work on data cleaning, where we are going to work on outlier detection and its removal. And then we are going to work with data set to work on feature engineering. And then we are going to work on building the final prediction. All right. So next we have, now first of all, we are going to work on EDA as an exploratory data analysis. So here we have to find out the different anomalies here. So we can find out the number of players. So we can run the statement as for I in ID, group and match ID. We can simply define what exactly we are going to, like how much data we have. So as you can see here, there are almost 4.4 billion unique ID. ID refers to player ID. There are almost 2 million group IDs, and we have the data for 47,000 match information. So again, this is a unique data set that we have the access to. All right. Now we are going to explore different match types available here. Like we have solo, duo, and squad. We are going to have three different type of match. We have solo, duo, and then we have squad. So we can play now. One play in solo, only a single player is going to be allowed. Then in duo, more than two players are going to be allowed as well. And then in squad, more than two players, as in we can play in a group of having just four members in a given group. That is going to be allowed here. So now, as a part of our EDA, we are going to first of all work on analyzing the kills. We're going to work on analyzing the number of kills achieved here. So first of all, we are going to find out. Now you can simply remove the output here. So basically here we are going to find out on average a person kills how many players. 75% of people have how many kills or less, while the maximum number of kills ever recorded in a game was how much, right? So to find out the answer to this question, we have to simply use a trained data frame. Now, to find out the average number of players kill, average number of kills, we have to find out the mean from the kills column, right, from the trained data frame. Then for finding out the data for like what 75% of people have how many kills or less. So here we are going to find out these 75 quantile, same as box plot that we discussed. So this is going to give us data that 75% of people have how many kills. And while the maximum number of kill ever recorded was how much. So you can see here, we can find it out by using maximum value from the kills column in train data frame. So we can run the statement. And you can see on average, a person kills around 0.9248 players. That means even less than one. 75% of people, they have one kill or less. That's how skilled they are. And then we have maximum kill ever recorded was 72 in a single game, not more than that. So this is basically based, now this is an actual fact, this is no hypothesis, and based on the actual data set recorded. All right. Now, same way we have to find out different insights here as well. That means now if we want to find out more data set, for example, suppose here we want to find out the effect of killing on winning plays percentage. So as shown below, by increasing the mean of winning plays percentage, we found that kill count was correlated with a target variable, which makes sense because more kills means usually a player is better skilled and will rank closer to the top, right? That's a fact. So for finding out, here we are simply going to make a copy of the train data frame and we are going to save it by the name of kills. And then we are going to have kill categories defined, where we are simply going to use the inbuilt function as cut available under pandas. And then we are going to find the number of kills. So -1, 0, 2, 5, 10, and 60. These are the actual number of kills. And then we are going to simply give the labels. So again, those who are having, suppose, no kills or they are killed themselves, then we have those who are having just 1 to 2 kills. Then we have 3 to 5, then we have 6 to 10, and then we have 10 kills, or we can say 10 kills plus. So you can see here, as the number of kills increases, the winning plays percentage also increases. That means we can see if a value is closer to 0, that means that has least chances of winning the game. If a value is closer to 1, then has the best chance of winning the game. So you can see here, as the number of kills increases, if a player is having more than 6, 10, or even 10 plus kills, then the chances of that particular player winning the game goes simply higher because that player is going to be skilled, right? So we can say that kill has a high correlation with winning plays percentage. Now, this is no longer a hypothesis. This is now a fact that we have got from the actual data analysis that we have done on the real data set available by PUBG itself. All right. So are we all clear till this part? Please give me a quick information, everyone, before we move further and start analyzing the effects of running on winning plays percentage. Are we all clear till this part? Please give me a quick information, everyone. Perfect. Thank you for confirming, everyone. So let's take a quick break here and let's be right back after the break so that we can continue our discussion on Effects of running on the winning place percentage. Thank you. please give me a quick information so that we can resume. Perfect. Thank you for confirming, everyone. So now we are going to analyze the effect of running on winning plays percentage. So here we can find out, okay, now how many players have walked for 0 meters. And remember, whenever we are working on the answers, we have to make sure that we do execute every piece of code, and that too in a given sequence. Because if we don't do that, then every code is connected to the previous code, right? So if you don't execute each and every code here, then we may not get the results, or we may get errors afterwards, right? Because the data frames are going to be created, and that's why they all have been linked to each other. All right. So now we are going to focus on analyzing the effect of running on winning plays percentage. Let's do that. Just a moment. So now here we can see, if you want to find out the like how many players they have bought for how many players they bought for 0 meters. That means either they died before taking the first step, or they have just joined the game and they are away from the keyboard, which is more likely possible, right? So to find out this piece of information, we have to focus on finding that data where walk distance is equal to 0 from the data frame that we have created. So once we execute the statement, then this is going to find out the piece of information from that particular data set where we have those players who have bought for 0 meters. And as you can see here, they are almost 2% players. They are almost 2% of players which have bought for 0 meters. So that means they either just leave the game after they have joined, or they are killed the moment they join the game. That may happen, right? Because of bad luck. And they are almost 2% of players who walked for 0 meters. Then we have to now, here we can simply plot it as a part of graph as well. That means if you want to find out the effect of walking distance on winning place percentage, then we are going to make use of Seaborn library as an SNS, just like we did import pandas as PD, numpy as NP. So here we have imported SNS. Seaborn is basically used for statistical analysis. So here we have imported Seaborn as SNS, and join plot is again an inbuilt function available under SNS. So using that, we have plotted winning place percentage data on the x-axis and the walking distance on y-axis. And then we have defined the data to be taken from the training data set, and then height to be 10 and ratio to be 3 and the color to be line. So this is going to plot this graph towards. So here we can see as the walking distance increases. So here we have the winning place percentage from 0 to 1, and then we have the distance traveled in meters. So as you can see, as the walking distance increases, the winning place percentage also increases, because it's a fact that if a player is able to walk for more distance, then player is still alive, right? And if player has managed to stay alive for a longer distance, that means the player is skilled as well, right? That means we can say that walking has a high correlation with winning place percentage as well. Same way, so basically we can find out at an average, a person drives for how many meters? 99% of people, they had driven for how many meters or less? Rider, this tag has been given to that player which has driven which has driven the longest. That means which has the most, I guess, which has the longest distance recorded in terms of driving in the game. And that has been noted as the rider. So as you can see here, for finding the average, we had to find out mean by using the ride distance column from the train data frame. And then we have to find out 99 quantile to find out how much distance has been traveled by 99% of players. And to find out the maximum distance, we have to find out max value from ride distance. So if we run this, we can see an average person. Okay, we may have missed on some data frame. And that's why this is not presented. And that's why we have to make sure whatever we are going to work on, we are going to make sure we do import the given data frame. So again, as you can see here, the runtime may have been broken. So that's why we can see that the runtime is not currently available. We can refresh this. But sometimes the runtime may be stopped. So we have to make sure that the runtime should be up and running. Because without runtime, no data frame, nothing is going to be up and running. So we have to wait for that to be refreshed. Just a moment. Just a moment. So here we have to read on all the statements for this one to be updated. So we have to make sure that now just to make sure that every data set has been successfully recorded, we can simply read on the statements. And if it is up and running, that means yes, the runtime has been restored. And now we can proceed further. And that's why we need Google Colab to make sure that the data set they are being plotted as quickly as possible, because when we have large data set, it usually takes time to process that. And this is a limitation that we observe as a common issue in local system. That's why we use Colab to simply improvise the performance of the analysis because we don't want to spend more time on creating the visuals out of it, right? And as you can see here, the on average, the person drives for almost 600 meters. 99% of people have driven for almost 7 kilometers, as in 6,966 meters. While the rider, that means the player who has driven for the most, the player has ridden for 40,707 meters, almost 40 kilometers, right? And now if we want to analyze the effect of riding on the winning place percentage, then same way we have to use the Seaborn library as an SNS. And by using the winning place percentage, we have plot winning place percentage on x-axis and the right distance on y-axis. And then here we have used the training data frame where we define the color as yellow. So as you can see here from the given table, we can see as the right distance increases, so does the winning place percentage as well. All right, as you can see here, as soon as the winning place percentage increases, the as soon as the right distance increases, so does the winning place percentage as well. All right. And that's why we can infer that yes, even right distance is having a positive correlation to winning place percentage, as we can see here. All right. So we can verify that yes, we are not a robot. All right. Now here we can also analyze the effect of healing and boosting. So in a game on average, a person uses how many heal items? 99% of people have used how many items or less, while the doctor has been the player who has used the most number of heals and boost items, that player has been referred as doctor here, right? So it simply means the player who has consumed most amount of healing and boosting items, all right? So as you can see here, now on average, a person uses almost 1.4 healing items. 99% people they have used 12 items or less. While the doctor, that means the player who has used most number of heal items, the doctor has used, or we can say over 80 items. And that has been found by using the mean, quantile, and the maximum value from the given columns. All right. And then if you want to compare both the values together, so here we can find out. So if we compare the values, then we can see that in terms of the training data set, we have defined heels, and now on heels has been defined plotted on the x-axis by using Seaborn, and boost has also been plotted on x-axis as a common axis, and on y-axis we have placed the winning place percentage, and then we have used blue color for the heel, the lime color for heel, and blue color for boost, and define the font size. And then for labels, we define the X label, the Y label, the title of the graph, and then we have used plot. Plot is basically the library that we have imported as a part of matplotlib, and then we have shown the library. So as you can see from the current library, we can see, although they both have the positive correlation in terms of winning place percentage, but as you can see here, the number of heals, again, it simply saturates. The effect of number of heals simply saturates after a given time, after the number goes beyond 2. But as soon as the player simply keeps on getting more and more number of boost items, it has a higher correlation as compared to number of heals, correct? So we can say that again, number of boosts is having a high correlation as compared to the number of heals items. And that's how we can say they in terms of in terms of comparison, they both have a high correlation, but number of boosts is having a high correlation than number of healing items. All right. So are we all clear to this part? Please give me a quick confirmation, everyone. Perfect. Thank you for confirmation, everyone. Okay, we have a query. Perfect. Thank you for confirming, everyone. All right, so let's proceed further. Just a moment. Now here we can see the effect of killing in different game. Here we can also see the part of data cleaning and how we can remove the outliers and how we can find the fraudsters. So the question is how exactly we catch the fraudsters in the game. So first of all, we have to understand what are the anomalies in killing. So the use of automated aiming software is without a doubt one of the most powerful cheats that can be used in player unknown battleground. All right. So it allows players to bind a key or mouse button to an auto aim and lock on function that is going to perform the activities for that auto aim. All right. So basically, it allows players to bind. Now, and again, it is one of the, we can say, most infamous tools being used here for getting a good score in the game. All right. And a trigger board can then be set to automatically shoot for us, and we can choose to shoot for us as well. So basically, before we can find anomalies, we also have to perform feature engineering as well. Now, this is what we had discussed yesterday. So feature engineering is basically extraction of Data pointers. Feature engineering is what? Extraction of multiple data pointers, correct? So we have to make sure again when we are working on finding anomalies, we have to find out a new feature as total distance. Now, this is what we can find out by adding ride distance, walk distance, and swim distance. So these things they have to be joined together to find out total distance. And then we have to find out the headshot rates. Now there are some hitmen, so we have to find out okay who those hitmen are. So for finding out the headshot rate, we have to find out. Now we simply have to calculate that from two values, from the headshot and number of kills. So we have to divide the headshot kills by the number of kills observed, and then we are going to find out the headshot rate where the value should not be 0. All right. So now we are going to find out those players having inhuman skill sets. So the question is it even possible now for those who have been active players of the game? Is it even possible to kill more than 40 people by acquiring more than 55 weapons and maintaining a total distance of less than 100 meters? Is that even possible, everyone? Is it even possible to kill more than 40 people by acquiring more than 55 weapons and maintaining a total distance of less than 100 meters? For those who have been active players of the game, we know that this is not, I guess, most likely not possible, correct? And that's why to find out this data, we had to find out the number of kills, right? So here we had to find out those data pointers where the kills is greater than 40 and weapons acquired is more than 55 and total distance is less than 100 meters, right? So we know that having 55 weapons in less than 100 meters is practically not possible at all, correct? Even though they may manage, now again, that's a big may. They may manage to kill 40, but again, acquiring 55 weapons in just 100 meters is not practically possible, correct? So again, if they are able to achieve this, again, complete forces. Again, we have to make sure that again we do have data pointers already selected, and again we can see these are different data pointers currently available, correct? So same way we have next question as is it even possible to kill more than 40 people without using any heals? So we have to again make sure that we are going to find out. So killing more than 40 heals, and again where heals taken are is equal to 0. So again we can see these are the values, correct? So we know that whenever we are playing the game, obviously the player is going to get hurt. At least they are going to have at least one bullet hit to them, right? So they're going to have at least one bullet hit. So they have to use either the healers or the bandage. So without using any of the heal items, they cannot go on. And that's why, again, these are also going to be considered as outliers. Just a moment. So 25 again is possible here. And you guess 25 even if it is possible, right? But 40 is something that is practically not possible at all. And that is what we take as a part of outlier, right? And again, when we are having these outliers, it's always good practice to drop these values, right? Drop these fraudsters. So for dropping the data set, here we can use train.drop. And again, we can see we are dropping those data set. We are having the number of kills more than 40, and the number of weapons acquired is more than 55, and the total distance travel is less than 100 meters. And then same way for those skill set having the number of kills more than, or you can say more than or equal to 40, and number of kills where is equal to 0. So you're simply going to drop these values, as you can see here. All right, and same way we can find out the other we can find out other outliers as well. So here we can find out those players who are having 100% headshot kills. Now, we had to find out the list of hitmen who have more than 10 kills and all the kills were done by headshot, a perfect kill. So either they are hitmen or they are John Wick, right? So again, the because again, it's a fact that majority of the players they are having a headshot kill in the ratio of max to max 10%, right? So that means they have killed 10 players and one or two can be a headshot kill, but not more than that. And again, if someone is having every kill as headshot, then obviously they are inhuman. They're having inhuman skill set, correct? So that is what we here to check on. So here we are going to find out those players whose headshot rate is equals to one. That means one means every kill has been done by using a headshot, and the number of kills is also more than 10. They can be one headshot, they can be two headshot as well. Suppose a player they have killed only one player. So there, in that case, a headshot can be one. But having more than 10 kills and every kill via headshot is not possible. And then we have headshot is where one and kills is more than 10 itself. And again, we can see that 24 players having this inhuman skill set. Then obviously they are using some kind of hacks and they are not going to be of any use if we include them in the model creation. And then we can also find out the players, those who are having kills without even moving. So we know that again, without moving, there cannot be kills, right? So if players are moving, because at the end, at least we have to move to at least acquire a weapon or to go out of the person of where we intend to kill, correct? So if the person is having 0 meters in terms of the kill, and they are having more than at least even if they are having one kill, then that is not going to be possible, correct? So again, as you can see, that 1,535 values having this data set, and that is something that we also have to drop. So we can simply find out the data set, and here we have simply drop it by using the drop function inbuilt in pandas frame, and where the kills without moving is set to true, and that value has to be dropped. All right. Same way, we had to find out those people who are having more than 10 road kills. Now, those who are on the road rampage, we know that more than now one kill, two kill, three kills is possible, but having more than 10 road kills is also not possible, and we have to drop these fraudsters as well. Now we have multiple wanderers. We have travel, lust, and wanderers. Those who are in the game only for the sake of travel. They don't have any intention of killing anyone, right? So again, they are peace lovers. But again, if they don't have any intention of playing the game, then they are of no use to us, correct? So we have to find out those players those who have more than 13,000 meters in terms of walking distance, and they have gone 13 kilometers even without getting killed or killing someone. That is also not possible, right? Either we will get killed or we will kill someone if we go 13 kilometers in a game. And again, we also have to catch these fraudsters as well. So you can see these are the available values that we have to drop. All right. So Just a common question. So, if we don't have any knowledge of the game, will it be possible for us to find these fraudsters? Everyone? Let's say if we don't have any knowledge of the game, so will it be possible for us to find these fraudsters? We won't be able to, right? And that's why we have domain experts. That's why we have domain experts. That means the people who are expert in one specific domain. For example, if we talk about healthcare, we have data scientists who are expert in the healthcare domain. We have experts in banking. We have experts in pharmaceutical. We have experts in the automation solutions, right? So we have to make sure that again we get the expertise, because if we don't understand the data set, we won't be able to improvise its accuracy, correct? And that is what we have to work on. So are we all clear on the process of finding fraudsters? Please give me a quick information, everyone. What is trending technology growing in India? Data science? Absolutely. So again, they are basically here we have the computer vision models again for object detection. They have been again in demand, especially since last and year after the pandemic, and along with the solutions for again for the tensor flows for building multiple object detection models. So again, they are in demand, especially for the India and APAC markets so far. Just a moment. Now, as a part of the project, let me just guide you on your assignment as well. So we have to go back to the LMS. Under the course content, we can find out the assignment for day 2. Let's open this up. Now, as a part of second day assignment, we had to find out, does healing improve the chances of winning the game? Here we had to use a correlation. Then we have to find out what is the effect of knocking, assisting, or reviving on the winning place percentage. And then what is the effect on the accuracy? MA refers to the model accuracy. If we are not improving or if we are not removing any attribute from the data, was it a good decision? And then we had to use feature engineering to create new features and check the correlation with the target variable. And then we just simply define highly correlated new features and calculate the accuracy of the model. And if we can further improvise the accuracy of the model, and if yes, then how exactly we can do that. So we simply have to work on including these different pointers in the notebook file. And once we are done, we have to click on the Submit Assignment tab available on top. And here we can simply click on Submit. So once we are done with the assignment, we have to simply click on Submit, and then our project is going to be evaluated and sent back to us after it has been done. And then we can start working, and then we will be getting certified accordingly. So are we all clear on the assignment process? Please give me a quick confirmation, everyone. So as a part of the assignment, we have to, first of all, download the same notebook file, and we have to work on adding these, performing the EDA on these pointers. That means here we have to find out, does healing improve the chance of winning the game? And what effect does knocking out, assisting, or reviving has on the winning place percentage? And if removing the outliers is a good decision or not. And then we have to and then we have to perform feature engineering to create new features. All right. And then we have to find out and again, we have to find out highly correlated new features that can impact the accuracy of the model. And once we are done, we have to simply go back and click on Submit Assignment. And we only have to submit the notebook file for evaluation. Is it clear now? Perfect. Thank you for confirmation. So since it is almost time now, so let's do one thing. Let's say we wrap it up for today, guys. And first of all, again, a big thank you to you all for being a part of this 2 days of journey. And if you really enjoyed today's session, then please do rate us excellent in the feedback form as a small token of appreciation for the hard work and time that we have put in. And let's hope to see you all soon join the entire session so that we can continue our journey that we have started today. So again, thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.